Hey everyone, I'm Brian Attwell, and I work on the same team as these fine individuals who came before me, the mobile platform team at Uber. There we go. I'm going to be talking about plugins. Strictly speaking, this is not a required thing to use with ribs. You can use it without ribs, or ribs can be used without this, but it's something that builds on top of ribs quite nicely. And it's also something that we've very heavily invested in when redesigning the Rider app. Earlier, Thomas talked a bit about some of the high-level goals that we really wanted to get out of redesigning the app, and I'm going to focus more on 3 of them. And in particular, I'm going to talk a lot about this first one, which is supporting Uber's growth for years, because if we're going to spend an entire year redesigning an architecture with a handful of engineers, and then 3-4 months with 100 plus 200 engineers, we better be damn certain that this thing is going to work well for us in a few years from now when we have even more engineers and even more apps, right? We'd better be certain that if we have hundreds of engineers writing code in the same app on the same day, because I don't know, maybe we operate in 2,000 cities in the world or something, that they're not going to be writing over each other's code. They're not going to be having crazy rebase conflicts all the time. And we also need to be certain that we can reuse code between, let's say, the 30 apps that we have in 2 years. Right now we have like 8, but maybe we'll have more. And so what this really comes down to is we want more code isolation, right? That's the big way that we get this sort of scalability. And we get a lot of that with ribs, but we want more. And to kind of walk through why this is interesting, I'm going to use an example that I hope you're all familiar with, and that's the product selection flow in the Uber app. Right. In this first screen, you choose, do you want an Uber X or do you want an Uber pool? And then you press this request Uber button. After that, you go through some different pickup refinement flows. Thomas earlier called them +1s. That's the name inside our code base. It's a terrible name. I'm going to call them pickup refinement steps from here on out. And in theory, there's actually up to 30 of these that you could see consecutively, but in practice, you'll never see that many. Fortunately, you might see 1 or 2, like one to refine your airport, to say that you're at this door so the rider, so that the driver knows which door to go to, or if you had a bad GPS, then we might ask you to put your pin on a map so that we can get a more accurate location than you would have automatically gotten from the GPS. The way that this looks, this is the rib diagram that Yi and Tony showed you earlier. You kind of see refinement down there on the bottom. It's nested under request because you would only need to refine your request when you're in the process of building a request, right? So it's like a subscope of that. I'll just draw some nice arrows around it. And because people in the back can't see it, let me zoom in. Okay, so here we have the refinement steps. This rib basically decides when the different children are attached and in what order they're going to get attached. And the individual steps, each one is just a single blocking modal, basically. These different steps, they're pretty well isolated already because we have ribs, but we don't necessarily have good isolation from the parent, from the airport step to the refinement step. And it can be pretty tempting when you're an engineer who's on a deadline to start kind of packing knowledge about each one of the steps into the parent. So suppose you're creating a new refinement step type, and you know that it should only be displayed when you have maybe the airport step before, or it should only be shown when the airport step hasn't been shown, but you have done the location refinement step. Or maybe you want some data out of one of these steps, and then you want to use that as input to another step. It becomes really very tempting to write that kind of one-off logic that knows the implementation details of these individual steps in the parent refinement steps area. It's of course entirely avoidable. You don't need to have one-off hacks there, but if we don't have any sort of enforcement that prevents that, nobody who's on a deadline is ever going to bother making certain that the refinement steps doesn't know about his parent. So this brings up the kind of obvious question of how do we avoid this? And the kind of obvious answer is we need some sort of plugin system so that the children here, they get executed inside the parent in a way that the parent doesn't know any of the details. We just kind of plug them into refinement steps. A kind of common way to do this would be to use dependency inversion, right? We could extract this refinement steps rib into its own library. Now it doesn't know, like literally cannot depend on any of the other steps or their implementations or their types, because it doesn't have a reference to that build target. And then you could inject all the individual steps into this library, and now you've got a version of refinement steps that can run a bunch of different individual steps, but can't have any hacks built around it. This is great for a few reasons. Great build performance, which is kind of an aside. We've got great isolation enforced by the compiler. But on the downside, it's undeniably complicated, right? We have like 80 places in the writer app where we would want to use a pattern here to enforce isolation between parents and children. And if we did dependency inversion like this in every single place, I don't think very many of our engineers would know what the hell was going on. I wouldn't. And also, it's debatable whether or not this is even better sometimes, because now, great, we have a parent of refinement steps that knows the details, that could potentially know the details of all the individual steps, instead of refinement steps knowing about them. And that means that potentially we have coupling at an even higher, more important, and more architecturally significant part of the app, which is awful, right? So what we did is a pretty simple idea. Obviously, we did not do this. What we did is we went back to the kind of more natural way of expressing this, which is you have the refinement steps directly depending on the individual steps, but we added this intermediary class called like a plugin registry. And it's pretty simple. It's just like a factory. It depends on all of the individual types, and the parent refinement steps asks the plugin registry to give it a generic list of the actual types. What's interesting here is that we have on Android used static analysis to enforce that the refinement steps can't depend on any of the types below the plugin registry or on any of the things that those steps depend on themselves. And on iOS, we've used like some interesting framework restrictions to make certain that this is enforced in a like build way. And now we've got like a pretty natural way to express this parent-child relationship, but we're certain that the parent doesn't know any of the details of its children, which is pretty cool. And it's a pretty simple idea. What else can we get from this? Because if all I was going to do was talk about code isolation, I would not need 20 minutes to do it. A much bigger problem in a code base with lots of engineers is how do you extend the application in a way that's predictable and kind of rational and thought ahead of time, right? Like if you have 30 blocking modals that are going to show up after you put in some product configurations, you don't want engineers thinking about different ways to do that extension, right? Like it should be a way that's thought out from a product point of view ahead of time and thought out in terms of like an architectural point of view ahead of time. And let's just take a look at some examples in the writer app for different plugin points, and I think the answer is going to get pretty obvious. So here we have the home screen, and I've boxed in orange different things that could be thought of as plugins. And in a lot of cases, these can be really thought of as lists of plugins. So like inside the home screen here, we've got a bunch of different things we call map layers. And all they are is really just ribs. In this case, they don't have views. They're ribs that have a map as a dependency. And they maybe, they watch some RX streams for like vehicles, and then they draw some vehicles on the map. Some cases are pretty complicated, like the fancy interpolation animations, and some of the cars are 3D. But from the parent point of view of the parent, it doesn't know that there's a nearby vehicles map layer, presenter location map layer, or whatever. It just knows that it needs to attach all 4 of them, right? And the outside of the consumer of these plugins is designed kind of like when you have the first plugin to be able to accommodate the fact that there'll be more than one of them. And then once you add a second one, there's really no more work or thought that needs to be put into how this will interact with other features. You kind of think about how will this part in the application scale, and then you start adding new things onto it. And there's a lot of examples that are pretty similar to that one, like the feed. It's really just a bunch of ribs in a list. Certainly, if you add a new feed card, you add a new type on the back end, but on the client, you'll register a new rib that knows how to handle that type, and then it'll just be showed in the feed. In a lot of cases, the applications can be built as just like lists of ribs that know how to handle different types of data. But there's cases where if you look into our app and also lots of other apps, you'll find that you kind of want to plug in a structure, but maybe it's not a rib. Maybe it's actually you're returning like an observable or like a stream in the case of location data. Like we have calendar location types from your calendar, and we have ones that are returned from geo, which is based on like our geo backend. Some based on your friend's location, which is a kind of zany feature. And someday maybe we'll have Yelp ones, I don't know, or care actually, because from the point of view of the application, it's just gonna be, give me all the plugins here, and I'm going to do a combine latest on them, and then I'm going to bind them to this UI here. And to go even further, sometimes there's no UI at all, of course, right? Like our most commonly used plugin point in the app is actually this like main scoped worker. When the main rib runs, there's a bunch of things you just gotta do, and 30, I think, different plugins registered to be run at this point of view. None of them have any views, they're just code that needs to run. So you have a main scope plugin like registry there. And there's lots of more examples like this. So what I'm kind of getting at is that once you have a formalized plugin structure, you start to find lots of places in your application that it makes sense to use and that you realize can be reused in a lot of ways. And as a result, I would claim that almost all features in the app can be written as code that plugs into the core of the app. And this is what we found in practice. Actually, only 20% of the app is written outside of plugins. So like 20% of the lines of code in the application layer are non-plugins. And I kind of have a bit more of an extended version of the rib tree here. I'm hoping that it's too small for any of you to read it because I wrote lorem ipsum in some of the boxes. But this is a bit more representative of the full tree, still a lot smaller than the real one. And the blue ones at the top there, those are the ones that are not plugins. So those are the ones that, and everything else, all plugins. Because what's really interesting about this is that the blue ones here, the ones that aren't plugins, are the ones that are the most architecturally significant, right? These are the ones where like, if they start to become aware of all of the features in the app, like these things will become totally unreadable and like incomprehensible, right? So these are the parts of the app that really need to be isolated from the features in the app. What that means is that because we can now say these are the things that are most architecturally significant, and these are not the things that are plugins, we have a clear definition of like the parts of the code that are non-features, that are architecturally significant, and that need to be reviewed very well. So we went and we said that things that aren't in plugins, they need to have extra code reviews on them. And once you do that, nobody wants to write code here, which is great, because we don't want this part of the code to actually be modified, right? If you write a new feature, we want you to, and we want ourselves to reuse the existing plugin points that have already been thought about, like how they integrate with the rest of the application and how they scale visually. We want those to be reused, and we never want any changes to the core of the app. And when that happens, the app just scales way more rationally. Okay, cool. So what else can we get out of this? At Uber, we write a lot of A/B tests, and I suspect that that's true of a lot of people here. Like it's pretty common mobile practice. Basically, every single new feature is written with an A/B test, and almost every diff and ideally every diff would also be written with an A/B test. This can kind of get crazy, especially if you don't clean up your tests once you're done with them. You'll end up having cases where like there's one test that like if this test is enabled, run this code, and then inside that there'll be another if this A/B test is enabled, run this code, and then it kind of turns into this crazy A/B test soup. Some of the things have been rolled out forever, so you essentially just additional cognitive overhead for no reason, and also because there's no often there's no kind of thought ahead of time experimentation strategy. People will write A/B tests around similar pieces of code in different ways, and things quickly kind of get crazy. So how can we go about fixing this? And the sort of obvious solution, given that I've been talking about plugins for 15 minutes, is that we will slap an experiment on every single plugin. We will say that every time you roll out a feature, you'll roll it out inside a plugin, and every single plugin will have an A/B test on it. What's really cool about this is it means we don't ever have to take these experiments away, because there's like a pretty clear boundary for where the experiments live. It's like pretty uniformly done. And as a result, we can keep these experiments around even after we've rolled them out for forever. And as a result, that means that we can turn off any piece of our code within that 80% of the code that's plugins. And we're confident of that because we write UI tests that run on every single diff that verifies the app still works with no plugins. I mean, obviously, it looks like ridiculous, of course, right? Like if you go to the map, you don't have an accelerator, and you'd be like, what's broken in this app? And if you look at a menu, there's not a single menu item. If you go here, there's no payments. So you'd better have set that up beforehand, because you're not setting up payments now. But you can still take a ride. And we have enough confidence that the plugins are isolated from one another that we believe we will never have to turn all of them off. So we know that we're never going to have to turn all of them off. And we know that even if we did turn all of them off, the app would still work. And as a result, we have confidence to say that if we have a crazy outage, we could turn off a few of them, and that would be fine, right? Okay, so now we've established that we've got code isolation, and we have like some product rails to build the application upon and to scale it rationally. And we also have this kind of rational experimentation framework for doing rollbacks and turning off features. And that's all kind of philosophical and great, but what has this actually been like in our experience? Engineers actually like it, right? Like engineers want to use plugins. It's kind of frustrating when you're an engineer in a large code base to know where to integrate your new features, and building out these plugin points, these plugin registries ahead of time saves a lot of cognitive effort. And that's why we've been able to pull off the fact that 80% of the code base isn't plugins, is because engineers actually want to do it. It's not like we forced people to, they did it. And as a result, we've been able to prevent outages because by turning off these plugins. Like we've, in the last few months, had 6 issues that would have been outages, which is to say, basically crashes that are really bad, like thousands of crashes a day, where we were like, oh, I guess I'm just going to turn off this scheduled rides thing. And I shouldn't have called it that team. I'm sorry, scheduled rides people. We're going to turn off this feature X thing, and then the outage went away. And what's kind of nice is that I said we had code isolation. And if you go and look at the top 3 layers of the rib hierarchy, you can read those things without knowing the feed exists. You can read those ribs without knowing that Alipay is even a thing. I think a lot of us might not know that Alipay is a thing, and I like to pretend it isn't. You could also go, and read all of those without knowing that, I don't know, well, maybe not +1. You could go and read those things without knowing that a lot of different payments providers are a thing. And as a result, it's now possible to understand the architecturally significant parts of the app and read them all and keep it in your mind as a single person. And if you can do that, then the application is actually comprehensible, right? So that's a big victory, but I've been pretty non-concrete. And you're probably all wondering do we have any numbers to back this up? Am I just spouting philosophy, and isn't architecture all subjective anyway? So let's pull out some numbers. But before I do, I'm going to talk a bit about this blog post that Joel Spolsky wrote. It's a really good blog post. Probably a bunch of you have read it. In this blog post, Joel Spolsky argued that you should basically never rewrite your app, right? He talks about Netscape and how they spent years redesigning their browser during the browser wars. It was going to be way faster. It was going to be easier to integrate new features with, and that would be a huge competitive advantage if only they had ever finished it, because before they did, they died, all right? So they went a bunch of time not developing features, and during that time, Microsoft ate their lunch. And even if it had finished, would it have been any better anyway? Because it was over the course of years, and a bunch of the engineers probably forgot what they did wrong the first time. With that in mind, how did it go for us? Okay, so what's a little bit different from us is that we had we didn't spend years doing it. We spent a year with a handful of people doing it, and then 3 months feature engineers worked on this. So it's not like we went years without developing features. And also we had this principled kind of upfront approach to architecture before we did it. And as a result, we've seen tremendous gains, right? Let's talk about development velocity. 4 months after this app is shipped, we're now seeing double as many diffs being landed a day inside the Rider app as 4 months before. Some of you are probably skeptical of that number because, I mean, debatably, it's a little specious. Can you compare a Git before, a diff before and a diff after? Maybe there's different amounts of boilerplate, but this matches the surveys and the anecdotal evidence that, yes, this thing is way easier to develop inside. And a kind of interesting statistic around this is that for a few weeks, we were landing 500 diffs in a single binary per week, which is tremendous, right? Like that's a large number of diffs to be landing in a binary per week. On top of that, the app is just better now, right? Like on the day that we shipped the new Rider app, it was more reliable and crashed less than the version of the application that we had been fixing bugs in for years, right? And that's largely a product of the fact that we now have an architecture that makes it possible to understand what's going on and that eliminates like stale state issues. And also we use Swift, which helps a ton, and also we use a lot of static analysis. But a lot of it is architecture and then other tooling that we've been able to build on top of the architecture because we have consistent patterns, right? Like you could not do really good static analysis on an ad hoc application with 3 different sort of developed as you go architectures. You need like a principled architecture and then you can build static analysis on top of that. And that's why we're now seeing not just better crash-free rates than before, but like 4 nines crash-free rate on iOS and 3 nines crash-free on Android, and those are both getting better all the time. In addition to that, like you've probably all noticed that the app starts like way faster now, and that's largely a result of code isolation. Like it's completely just an architectural thing that allows this app to start fast. When you isolate the code, it means you can just not run some of it when the app starts. And it also means that like, for example, we've got this separation between plugins and the non-plugin code. We can identify the code that is structurally important and that needs to run when the app starts. That's the non-plugin code. And the other stuff, well, we just don't run it during the start of the app. Like we just say, we're gonna wait until the location editor shows because like, users like to see that their app is doing something when they open it. So we're just gonna kind of defer that and then we'll load the map, and then after that, the plugins can run. Because like, let's be honest, you don't need to press the, I should stop against scheduled rides. You don't need to press the scheduled rides button like immediately when the app runs. You wanna see the map in a location editor. But perhaps most interestingly is the NPS score change that we've gotten. For you, those of you that are unfamiliar with NPS, it's like, how likely are you to refer this thing, in our case, architecture, to someone outside the company? So we asked engineers inside our company, how likely would you be to refer the current architecture to people outside of the company? And we asked this a year ago, and we asked it a few more times, and then we're asking it now. And the change has been 78.5 points. So, and so I guess to summarize, to go back to Joel Spolsky, we feel like it was worth it. And we also feel that it can be tremendously valuable to think about, to both have this architecture, but also to think about your architecture in a principled way before you go about writing the application if you have that liberty.